Hello and welcome to today's video. We will be looking at Introduction to Matrix Algebra. Now, a matrix is a rectangular array of numbers whose value and positioning is significant. The value and the positioning of these numbers is quite significant, and we'll be looking at why that is the case in a short while. The size of a matrix is given by the number of rows and the number of columns. So the size of a matrix is given by the number of rows and the number of columns. What do I mean by this? I mean rows by columns. Rows by columns. If you can't remember, just use remember Roman Catholic, row, column. So the symbols used are M by N, row by column. So for example, let us look at a matrix whereby we have the following numbers, the following elements, right? Yes, you show matrices in brackets. So this means that the rows, where are the rows? Those are the rows. The columns, let me write for you guys, rows and columns. Columns. These are the rows going like this, columns. So you say 1, 2. That is a 2. You start with the rows 1, 2 by 1, 2, 2. So that is the rows, columns. That is a 2 by 2 matrix. Yes. So now you can notice that the number of rows, we have 1 row, 2 rows, and the number of columns, that is 1 column, 2 columns, are equal because we have 2 rows and 2 columns. When we have equal number of rows and columns, we say that that is a square matrix. A square matrix. Now this is a matrix where the number of rows equals to the number of columns. That is what we call a square matrix. For us to understand, let us look at other examples. Now let us look at a matrix with the following numbers: 1, 7, 8, 4, 9, 3. Now that's just an example. Remember, the following are the rows, and these are, sorry about that, these are the columns. So what is the size of this matrix? You start with the rows, 1, 2, and then the columns. So we're going to say it's a 2 by 1, 2, 3. 2 by 3 matrix. It is that simple. It's a 2 by 3 matrix. Let's look at another example. We have a 1, 4, 7, 9, 8, 3. Remember, you use brackets on normally on matrix. This is a 1, 2, 3, a 3 by 1, 2, 2 matrix. Yes, I hope we're together up to there. So let's look at another square matrix like the one we started with. Let's say you have the following numbers: 7, 9, 2, 8, 3, 1. Now this is a 1, 2, 3, 3 by 1, 2, 3. That is a 3 by 3 matrix. What does that mean? It means that the number of rows equals to the number of columns, making it a square matrix. Now that is very, very clear. Now let us look at something called vector or vectors. If you have a single row matrix, this is what we call a row vector. Yeah, a single row matrix is called a row vector. For example, let's just borrow from here. If you have the following numbers, that is a row vector. It has a single row. Now a single column matrix is called a column vector. For example, we have the same elements, the same numbers, 6, like so. That is a column vector. Like so, I'm sorry. That is a column vector. Now, another thing that's important to note, if you're given a matrix and you're required to find the element, a certain element. So let's say we have this matrix. This is matrix X, and we are to find X, 2, 3. Yes. What does this mean? Remember, we said you start with the rows and then you go to the column, that is M, N. So you're being asked, on matrix X, can you give us row 2, the element in row 2, column 3? So assuming that this is matrix X, we're going to look at row 2. Remember, the rows are going this way, so it is 1, 2. So what element do we need from row 2? The one that is in column 3. So 1, 2, column 1, 2, 3. That makes it this element right here. That is the elements on row 2 and column 3. That is the element we were looking for. The first row, the second row, column 1, 2, 3. That's the element we're looking for. So we are now going to look at manipulation of data in matrix, and that is matrix algebra. Now, manipulation of data in matrix is done through matrix addition, matrix addition, matrix subtraction, matrix multiplication, and matrix inversion. So we are going to look at matrix addition and subtraction. Matrix addition and subtraction. Now, for matrix addition and subtraction, and or let's deal with addition first, for it to take place, or for two matrices to be added, they must be of the same size. Must be of the same size for the matrices to be added. They must be of the same size. Remember, we looked at how to know the size of a matrix. Now, this means they must have the same number, must have the same number of rows and the same number of columns for addition to take place. For example, let us look at matrix A with the following numbers: 1, 6, 5, 2, 8, 5. That is matrix A. And you have matrix B. Let's write it here. Matrix B, which is 3, 2, 1, 6, 9, and 2. So the first thing you're going to check, are these matrices of the same size? So 1, 2, 3, 1, 2. This is a 3 rows by 2 column matrix. That is a 3 by 2 matrix, and then this is a 1, 2, 3, 1, 2. 3 by 2 matrix. So can they be added? Yes. A plus B is possible. Now let us look at how do we add these matrices. So what is A plus B? You're going to write the matrices down. 1, 2, like so. Plus B is 3, 2, 1, 6, and 9, and 2. How do you add this? It means 1 plus this 1 plus this 3 plus 3, 6 plus 2, 6 plus 2, 5 plus 1 plus 1, 2 plus 6, 2 plus 6, 8 plus 9, 8 plus 9, 5 plus 2. That will give us A plus B. So we solve that out. 1 plus 3 is 4. 6 plus 2 is 8, 6, 8, 17, 7. Yes, so that is what the answer of A plus B gives us. Okay, so remember we've just taken this plus this, 6 plus 2, like that you arrange them. So A plus B is 4, 8, 6, 8, 17, and 7. Quite simple. Now it is important to note that A plus B is the same as B plus A. It does not matter in which sequence the matrices are added. If you add A and B or add B to A, they are the same. Yes? So why is this? This is because the matrices are of the same size. So if the matrices were not of the same size, they could not be added. So you add matrices of the same size. So it does not matter the order in which you add them. A plus B is equals to B plus A. I hope that is understandable. Now let us look at